All right, welcome everybody. So this is section 1.7, where we're going to deal with inequalities, linear and absolute value inequalities. Okay. So the nice thing is that most of the things that you have been doing with equations so far, you can just continue to do with inequalities. So in other words, if you had something like, 2x minus 1 equals 5, you wouldn't really treat that too differently than if I had an inequality instead of an equal sign. Okay, so like a greater than sign, a less than sign, etc. So let's just kind of go over our signs and maybe what is different. Most things are the same. Okay, well then let's talk about what is different. So first of all, let's make sure we know how to say these symbols. Okay, so the symbols that we have. Okay, we have. Oops, sorry. I have to do. All right. We have this one. This one. Oops. Okay, so what each one of these stands for. So this one is actually going to be called less than. Oops, I'm still underlined. All right. Wow. Okay, I will eventually get the underlining off. There we go. So this is less than or equal to. Okay, so less than is anything that's going to point towards the left. Okay, so that means that down here, this one's also going to be a less than. If you hold up, a trick someone taught me at one point in time is if you hold up your left hand, right? Your left hand, there's your thumb, right? And then that's horrible. I don't even know if I should attempt to draw this, but hold up your left hand. Your left hand actually makes a less than sign, right? That's your thumb, and you've got your four fingers. I'm going to attempt to draw it, whatever. Here's your less than sign. And they said people use their left hand, most people use their left hand less than their right hand. Okay. Another more simple way to think about it is the mouth eats the bigger number, right? So if the mouth is opening towards this side, then whatever's over here must be less. So that's why we call it a less than sign. Okay. And then, so of course that would leave these others to be greater than signs. So this one is going to be a greater than or equal to because it's got the line underneath it. So on. Sorry, guys. I feel like I'm turning it off. Oh, I see. I got to turn it off sooner. There's my problem. Okay. So this is going to be greater than or equal to. And then this one at the bottom will just be greater than. And so similarly, if you hold up your right hand makes a greater than sign. Or like we said, of course, if it's pointing this way, then this number must be the greater number because the mouth always eats, the alligator eats the bigger number, right? Okay, so what, besides knowing how to say these, and what we have to know, I mean, if numbers are there, it's pretty dang obvious 7 is less than 8, right? But why do we care? Numbers aren't going to be there. There's going to be variables there, right? And so with the variable there, you really don't know if this thing is bigger or smaller. So you do have to know how to read this sign, right? So X must be smaller since the mouth's opening towards the 9, right? So X is less than 9. All right. So what is different? Let me insert a slide here, okay? So the big thing that you need to know when it comes to inequalities, right, is that anytime you multiply or divide by a negative, you have to switch the sign. You have to flip the inequality. Okay. So let's just do a quick thing because my teacher just told me that. And I was like, aye, Captain, But let's just kind of show it to you because then you'll be like, oh, that makes complete sense. I get it now. So we'll start off with an inequality that is true, right? Okay, so 2 is greater than 1. Now, what I'm going to do is I am going to commit a math sin. So I am going to multiply or divide both sides by a negative. So let me go ahead and divide by a negative. Okay, I'm going to divide by a -1, you guys. This is mostly division that we do in this class, you guys. So that's why I'll choose division. And I'm going to not flip the sign. Okay, so let's commit a math sin. Oops. Math sin and not flip the inequality when we divide by negative. Okay. All right, so why is this so bad? I mean, so what? I didn't flip it, right? Well, let's see what's left over. Okay. So 2 divided by -1, well, positive divided by a negative is negative, right? And then 2 divided by 1 is 2. So this is -2. I'm not going to flip the sign. 1 divided by 1 is 1. Positive divided by a negative is negative. Now this is not true, right? If you have a number line, here's 0. You go this way, here's -1, here's -2. -2 is not greater than -1, right? -1's bigger than -2. Anything to the right is bigger, right? Okay. So -2 is not greater than -1. So we need to flip. Okay. So that's the reason why. When we first started off, it's true, but when we go into negative land, it would no longer be true. So we have to make sure that when we flip, that when we divide, so after this step, right, it would have been proper to, on the next line, have made sure that I flipped it to be like this. Okay. All right. So let's proceed to do these. Find out. I feel pretty comfortable. Not a lot has changed, which is good practice for us, you guys. All right. So we're going to go ahead and distribute the 3. Now, there's 2 schools of thought, and I really don't care what you use, you guys. I'm just going to point them both out so you can have a strategy and use that on all your problems, okay? So 2 schools of thought. Might be more, but no, there's not. 2 schools of thought. So the first way, method 1, is get the variable on the left. Okay. Second way is try not to have any negatives. And we'll go through and I'll explain these, you guys, in case you're like, what is she talking about right now? You probably shouldn't know. All right, so for the first one, if my goal is to get the variable on the left, then let me go ahead and take this inequality. I thought I Control-C it one more time. Okay. So if we want to get the variable on the left, then we would have to take away 5x. So we get -2x plus 12 equals -8. So now you can see that the variable's on the left-hand side. Oops, an equal sign. Hello. It's like my #1 mistake, guys. Everything becomes an equal sign. All right, the variable is on the left. Okay, now let's go ahead and proceed through here. So -12, -12. Right here, I'm going to be dividing by a negative. And that's going to require me to remember that I need to flip this sign, right? A negative divided by a negative is a positive. Okay, so x is less than 10. Now with the other way, so the con to this one, why people maybe wouldn't do it, is some students forget to flip the inequality. That would be me. And so when they divide by a negative, so they would end up getting it wrong. They would have a chance to get it wrong. So the reason why some people might do the second method is that. All right, for the second method, we try not to have any negatives. So instead of moving the 5x, I'm going to move the 3x because now I do not have a negative. you'll notice that it's going to be a positive 2x, unlike on the last one where we had a negative 2x, right? And then we'll proceed as we did, 8, 8, 20 is greater than 2x, divide by 2. Now this one is one step longer, which is why people might not choose to do this one, okay? We never leave the variable on the right in mathematics, and that's just because that's really harder for people to understand. Instead of telling people 10 is greater than x, you want to tell them x is less than 10. 10 is greater, then x must be smaller, right? So we're going to flip this guy around, and when you flip it, you have to flip the sign too. 10 is greater than x, or x is less than 10, okay? So they get you there, pros and cons, pro for this one on the right is obviously I didn't have a negative 2. So since I never divided by a negative, I didn't have to flip the sign, right? Over here, I had one less step would be the pro to that one. All right, so take your pick. So graph the solution set. Graph the solution set and write the solution set in set builder and interval notation. So let's move into that now. Let's go ahead and get this into set builder and interval notation. Okay, so we got set builder. All right, for set builder, it's pretty easy. You're just always going to write the squiggly brackets, and you're going to put x such that. And you're going to slide in your answer. So there's your solution set, all x such that x is less than 10. Okay, so you're telling people, hey, what numbers are going to work, for this inequality up here? What can I plug in? Well, any number, as long as that number is less than 10 is what this is saying. Any x such that x is less than 10. You throw a 9 into this, it's going to work, you guys. You throw an 8, it's going to work, right? Or 9.1, it's going to work. All right, a little bit newer and trickier is the interval notation. And here's where maybe a graph first would be helpful, right? Okay, I'm going to go ahead and put 10 on my graph. Now, x is less than 10. So that means that I want to shade this way. This is where the lesser numbers are, okay? And we're going to go ahead and since it's a less than, we're going to use a parentheses that's going to open up towards your shading, okay? So let me talk about why I'm using a parentheses. So just really quickly off to the side here. Let's get those symbols. The less than or the greater than, use parentheses. And then if you have the line underneath, if you have the or equal to, okay, so let's go ahead and do this. The less than or equal to, or the greater than or equal to, you use square brackets. So let me put this in a little bubble here, you guys, so that way you know that this is really important stuff here. Okay. All right, so we chose a parentheses because we had just a less than sign. There was no bar underneath it, right? Otherwise, I would have used a square bracket. So now I'm going to go ahead and describe what I've shaded in red. Okay, so for interval notation, the furthest to the left, well, there is no furthest to the left. It just keeps going to the left forever. So furthest to the left, we would call that negative infinity. Okay. The furthest to the right we ever go is 10. We kind of stop at 10, right? And we already know that 10 gets a parentheses because we already talked about it. Now, as for infinity, infinity or negative infinity always gets, I probably shouldn't have clouded this, you guys. Let me delete this cloud if I can. I cannot delete this cloud. Sorry, it's weird. This program at home versus on my smart board at school behaves differently. So, all right. Okay, so let me put that in here too. Let me go back to this. Is it gonna let me into this, you guys? There we go. All right, and so infinity or negative infinity, right? Always gets parentheses. no matter what. So you will never put a square bracket on an infinity, you guys. You will always be putting a parentheses, okay? All right, so as soon as I see an infinity, I'm not even thinking, right? So what this does is this tells people, okay, it's going to be all the numbers between these two, right? So anywhere from negative infinity all the way to 10, I could pick any number in between there, okay? And the square brackets, right? If I had put a square bracket on the 10, that would let the reader know, oh, okay, and I can also plug 10 in and it'll work. When you don't have a square bracket on the 10, you have a parentheses, you're saying all the numbers between, but don't include 10. Okay. All right. I think we did everything that we needed to on that one. Let me go ahead and put a little box around this because this is part of the answer. Okay. All right. Let's try another. Same set of directions, you guys. So we're just going to do a bunch till we become professionals. All right, and we're just going to go ahead and combine like terms. So we're going to do the 8x minus 3x, which will get us 5x. And then we are going to do negative 16 plus 5. Okay. And I'm just going to go ahead and add the 11 over. Yeah, the variable's on the right, but don't worry, we'll fix it when we get done. So this will be 27 divided by 5. So we have 27 over 5 is less than or equal to x, or if we flip it around, x is greater than or equal to 27 over 5. So make sure you flip the sign too, you guys, okay? So if we were to do a little graph for this, right, it's a tiny graph, we've got 27 over 5 here, okay, which just plug that into your calculator because I think on Connect Math, you have to like put the dot on a number line. So that's going to be 5.4 or 5 2/5, you guys. Okay, so you'll know to put it somewhere between 5 and 6, right? Closer, a little bit closer to 5. Okay. All right, so let's go ahead and do our set builder and our interval notations. So for set builder, we're going to go squiggly bracket, all x such that x is greater than or equal to 27/5. For our interval notation, which by the way, you guys, that's my favorite, and that's probably what I'll have you guys doing on the final at least. It's going to, let's shade, I forgot to shade, huh? So since it's x is greater than 27 over 5, we're going to go to the right. That's where the greater numbers are. Because there is a line underneath, we're going to make it a square bracket. So for the interval notation, it's going to be square bracket 27/5. That's the number furthest on the left. And furthest on the right, well, it just keeps going to the right forever. So it's going to be infinity. When you write your interval notation, make sure you always go smallest, comma, biggest. I get some students who will do something like this. They'll go 5 negative infinity, right? And I already know they're wrong because the smallest number has to be on the left. Negative infinity, you guys, that is as small as it gets. That's going to the left forever on a number line, right? Look at our last example. It's going this way forever. That is really, really small, right? Bigger numbers are to the right, not to the left. So this is automatically backwards. So make sure you go smallest, comma, biggest, or the one on the left, comma, the one on the right, whatever. Okay. And remember, infinity always gets a parentheses, so that is why I put a parentheses on it. So they might not necessarily match. One might be a square bracket, one might be a parentheses. Maybe they do match, you know, who knows. Okay. All right. So for this one, if you're somebody who doesn't have a calculator, then moving the decimal is very beneficial, right? So I'm going to go ahead and do that so that way I can keep integers or whole positive or negative whole numbers on here. Okay. So let's move the decimal once to eliminate decimals. every number has a decimal, right? But you guys know what I mean. Okay, so I'm going to only move it. Remember we said, don't do it to the stuff inside the parentheses. Only do it to the stuff outside the parentheses. Because in a second, those things that are outside of the parentheses are going to distribute into the parentheses. So you don't want to double do it. We multiplied by 10. That's what moved our decimal place once. If I multiply by 10 to this number, and then this number is about to distribute in, well, then those are going to get multiplied by the 10 too. So don't double do it. All right, so we might as well go ahead and do our distributing. And take your pick. You know, I don't care. Maybe I'll use the get the variable on the left technique just to keep you guys on your toes with the dividing by a negative thing. Okay. All right, so this is going to get us negative 2x. So I have my variable on the left-hand side. I'll add my 12. Now, right here, we are dividing by a negative. This is a big step. Since we are dividing by a negative, we must flip the sign on the next step. Okay. All right, so remember to do that. So it's going to be x. I'm going to go this way now. Went from a less than sign to a greater than sign. All right, so on our little graph here, we'll put a 9 on it. I love these graphs. They're so easy, right? Just put the number on there. All right, greater than, which means shade to the right. Now, if you have the variable on the left, then you can actually just look at the arrow and shade the way that it points. See how it's pointing towards the right and we shaded towards the right? If you go back here, this one points to the right and you'll notice that we shaded the right. You go to our very first one, this one right here, it points towards the left and we shaded on the left, right? So it's a kind of cool trick. You have the variable on the left-hand side, just go the way that the arrow points, okay? All right, pop quiz yourself right now. Should I have a parentheses or a square bracket? Hopefully you said parentheses since there is no or equal to, right? So we're going to go ahead and have a parentheses on this guy. There's no line underneath. If there were a line underneath, it would have been a square bracket. All right, so let's do our set builder and our interval notation. So set builder. So our set builder we know is just the squiggly bracket one. So put your squiggly bracket, all x such that, insert your solution. The interval, we've got to look at our graph to get that, right? So the smallest that I see on the graph is 9. And it just keeps going to the right forever. So the biggest would be infinity, which I know is a parentheses. And we already know 9 is a parentheses too. We already discussed that. All right, let's go to the next one. So similarly to the last one, let's get rid of the fractions. I don't want to deal with the fractions, you know, I don't want to have to bust out my calculator. So let's eliminate the fractions by multiplying by the LCD to all terms. All right. So the LCD, the least common denominator, I'm looking at the denominators. I see 4, 3, and 2. So I'm thinking that the LCD is going to be 12. If we multiply everything by a 12, that should do it, okay? All right, let's go ahead and do some canceling. 4 goes into 12 3 times. 3 goes into 12 4 times. 2 goes into 12 6 times. We have no more denominators, folks, so we no longer have fractions. So we're going to multiply the leftovers. So we have 3 times 1, right? Don't forget your x. Then we have 4 times 2, which is 8. And then we have 12 times x. And then we have 6 times 1. All right, so now way better equation to deal with. I do not have to work with fractions. All right, so we got 3x plus 8x plus 24. Let me go ahead and combine the like terms. You got a couple of x's over here. So 11x. Let's just do the variable on the left again. So I'd have to move the 12x over. Minus 24 to both sides. And again, big moment because I am about to divide by a negative, right? Since we divided by a negative, flip the sign on the next step. Let me hit caps lock. Flip the sign. How about flip sign on the next step? Okay. So it looks like it is going to be x is less than or equal to 30. So if we get our little graph out, there we go. We've got 30 on our graph, less than, where the arrow points to the left. So we're going to shade this way. And because it has the line underneath it, right, it's going to be a square bracket. All right, so we've got our set builder and our interval notation. Number one reason I get emails on this homework assignment is because people didn't read the directions. They're typing in the interval notation and they didn't realize that the directions wanted set builder or vice versa. I think it's tricky. I think Connect Math keeps changing it up on you. So you have to constantly be thinking about it. And I mean, who reads directions in math? A lot of times we just dive in. So I totally get it. So that's why I wanted to make sure that you guys are aware of it so that when you do the assignment, you're looking at the directions and going, okay, which way does it want my answer? Okay. All right, so we got squiggly bracket, all x such that x is less than or equal to 30. For the interval, it's staring right at us. It's going to the left forever, so negative infinity. The biggest number I see on the shading is 30. We know infinities always get parentheses, and we know 30 got a square bracket. We've already established that. All right, so the last two have been eliminating decimals and eliminating fractions, just giving us that practice again since it's been a while. All right, so we're going to go ahead and, oops, sorry guys, go ahead and distribute. And we're going to go ahead and combine like terms. So the negative 9 plus 17. Go ahead and combine 2x and 1x to give us 3x. Ooh, okay. So this one's weird because when we go to like take away the 3x, you'll notice that all the x's fall off the paper and we get this. So when the x's disappear off the paper, when the variables go away, just check to see if the remaining statement is true or false. So when all of the variables go away, check to see if the remaining statement is true or false. All right, so let's see if this is true or false. X is less than or equal to 8. Well, if it had been a less than, you can't say I'm sorry, 8 is less than or equal to 8. If it had been a less than, 8 is not less than 8. But because it's an or equal to, this is a true statement. 8 is less than or equal to 8. Okay, so that or equal to saved us, right? Okay. So that means that this is going to be like before, an all real situation. Okay, so the solution is going to be all real numbers. That's going to be our solution. So on our graph, we would just have to shade, just put a 0 on it, I guess. Oops, do that in black. Just or something on it. But we're going to just shade the whole dang thing, right? Da, 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 arrows, arrows. Every single number is good. So what would they put for set builder? Let me think about that. All x such that x is real. That's one way to write it, like that. All x such that x is a real number. You could just physically write it out. I don't know what they're looking for on Connect Math, any one of those two. Remember, this is the bolded R, you guys. It's like you draw and 2 lines and then you draw your R. Okay, so that stands for the real numbers. Okay, so either one of these is fine with me, okay? All right, for the interval, this will be the first time we've written this, but negative infinity to positive infinity, right? It goes all the way to the left, sorry. And it goes all the way to the right. And we know infinities always get parentheses. Okay. All right. Let's do the whole get rid of fractions thing again. So the LCD between 4 and 2 is 4. So I'm going to do a times 4 here. I'm going to do a times 4 here. I'm going to do a times 4 there. So that's going to get us 4x is greater than, and we're just going to cancel the 4's here, right? So just 2x plus 1 is left. And then we're just going to cancel here. 2 goes into 4 twice. 2 times x leaves us with 2x. So this 2 is going to be one of those funny cases because 2x plus 2x is 4x. Okay. I can see right now that if I subtract 4x from both sides, that the variables go away again, right? So we just have to see, is this a true statement or not? Is 0 greater than 1? No, right? That's totally false. Okay. 0 is not greater than 1. So instead of having all real numbers, we're going to have quite the opposite. We're going to have no solution. Okay. No solution. And then, so that if you were doing set builder, right? That would just be the empty set. There would be nothing inside of it. I haven't seen them do like a interval notation for that, you guys, so I would not worry about that. I mean, there's some silly stuff that you can do, like from 5 to 5 and don't include 5. I don't know, but it's silly, utter nonsense. So they'll probably just ask you for set builder on one like that. So oops, so don't stress out about that. Okay. Or maybe they might have you pick no solution from a drop-down menu. Can't remember, you guys, right now. Oh, so graphing it, huh? If we graph it, you would just have a number line with nothing on it, just a 0 and nothing's been shaded. It'll just be empty, right? Okay. All right. Now I told you I was really guilty about not reading words. I just dive in and do stuff, and I read the directions afterwards. A lot of times I'd get stuff wrong, and then I go read the directions, and I'd be like, oh, okay. So I want to point out that these words and or are so very important, okay? And means that we're looking for the intersection, or means we're looking for the union. Okay, so see if I what I need to say here about that, you guys. Okay. So for and, you're looking for the overlap, okay? for and, look for the overlap. For or, you're going to look for, you're going to take it all. What I mean by that is, let's consider the following Venn diagram. Okay. So if I have a Venn diagram, do one that can overlap. And we'll just put people who like cats, cat lovers. And over here, we'll put dog lovers. Okay. So if we were to shade people who are cat and dog lovers, right? People who are cat and dog lovers, just like animals. Okay. If we were to shade that, that would be the overlap, right? That would be right in here. They're inside of the cat loving bubble. They're inside of the dog loving bubble. So they must love both. Okay. Now for, if we took that same scenario, that same Venn diagram for ors, okay. Well, we would actually shade everything, you guys, is what we're saying. For when we say for or, shade it all. Okay. And some of you might be going, what? That doesn't make any sense. And you're right. And here's part of the reason it does not make sense. In math, we use the exclusive or. I'm sorry, we use the inclusive or. What am I talking about? We use the inclusive or. And what that means, let me put this in English, we use the exclusive or. So, like somebody, my understanding of or in English is like either you're blonde or you're brunette. There's no like, oh, that person could be both, right? Either you're a guy or a girl, you know, either that animal is a dog or a cat. That is what we would call an exclusive or. It's one or the other, but not both. Okay. That is not the case in math. In math, our ors can be one, the other, or both. Okay. So let me elaborate on these a little bit. In math, we use the inclusive or. In other words, it can be one, the other, or both. In English, we use the exclusive or. So it can only be one or the other. So, I mean, what does that do? That would make a different, if it was English class, this Venn diagram would have been different. But I would have been circling or shading people who like cats or dogs. I would have only shaded in here, in like this area. Sorry, let me get my pen out. In here or in here, because it's an exclusive or, saying it's one or the other. Either you like cats or you like dogs, right? Okay. But since we're in math class, we're going to allow or people who like both. Okay, so I just want to make sure that that's really clear. So that's why we say when we see an or, take it all. Now we're not really going to be doing Venn diagrams, you guys. We're going to be graphing on number lines. But I think the best way to explain it is through these Venn diagrams, you know, for why I'm taking the overlap for the ands and why I'm taking everything for the ors. All right, so let's go ahead and dive in and do a few of these. Okay? All right, so I see the word or, so I'm going to keep that in mind as I go about solving these, you know, inequalities here. Okay, so here's what we have. X is greater than 5 or X is less than 4. So what I like to do, and I don't know, I should probably go watch some YouTube videos to see how what other people are doing, but this just makes sense to me and it works, so I do it, is I draw 3 number lines. The third one is my final answer. Okay, so this is going to be the number line for the X greater than 5. This will be the number line for the X less than 4. And this will be the number line for both for my final answer, okay? So I'm going to put the numbers 4 and 5. So that's going to be 4 on all the number lines. And that's going to be the number 5 on all the number lines. All right, so I'm going to shade X is greater than 5. So that would be this way. And it'd be a parentheses because there's no line underneath. X less than 4 would be this way. And that'd be a parentheses. Now, because it's an or, that means we're going to take it all, right? Take it all, anything that's been shaded. So I'm going to take both of them and put them together on the same number line. And that is going to be my answer, you guys. So I'm going to box it. This is what I would put in to connect math if I had to graph it. So let's go ahead and do our set builder and our interval notation, just like we've been doing on all of these. By the way, it's important that you do the graph first, guys. I have some people who do it the other way around and they end up getting it wrong, okay? So if we do the set builder, it would just be squiggly bracket, all X such that X is less than 4, or X is greater than 5. Now for the interval notation, we actually have 2 separate pieces, 2 disjoint pieces, okay? So when that happens, you'll describe them individually. So the first one would be from negative infinity all the way up until 4, parentheses, parentheses. The second one would be from 5 all the way to positive infinity. And we put this upside down, this U, not upside down U, we put this U, which is called a cup, okay, union symbol, to just kind of show that we had 2 disjoint pieces that are both going to be part of our solution set for this inequality. Okay. All right, let's try another one, you guys. All right, so again, just bust out your awesome solving skills. I'm going to go ahead and subtract 10x. And then add 12. I found students like to have the variable on the left. It was almost 50-50, but more people like the variable on the left. So I'm going to go with that. We divided by negative. Don't forget to flip the sign, guys. Okay. And then let's solve the other one. Thank you for a nice, easy one. We'll take it. Okay, let me just double check my math really quickly. That looks good. Okay. Now this time it was an and, right? So I'm just going to write it on down here. All right, so I'm going to get my 3 going. 1, 2, 3. So first one's going to be the greater than or equal to -3. The second one is going to be the less than 2. And the third one is going to be the combination of the 2. X is greater than or equal to -3. And X is less than 2. All right, so it looks like, remember, go smallest number on the left. So -3 is the smallest. Some students get it wrong because they just have a moment. And they don't put the smaller number on the left, especially if they're both negative. That's when I get that. All right, X is greater than -3. That's this way for the -3. Square bracket, because there is a line underneath. Less than 2, that's this way. Parentheses, because there is no line underneath. Now, it's an and. So I have to look for where the overlap is. You know, what do these two have in common? Where's the overlap? Well, you can see that the overlap is in this region right here. That's where they're both shaded, right? So that's what I'm going to shade on here. And then you just keep their signs respectively, right? So square bracket was on the -3 and parentheses on the 2. Okay. So this is going to be our answer as far as the graph is concerned. So let's go in here, get our set builder and our interval. Okay. So for the set builder, you don't want to use this. This is why I said a second ago, make sure you do the graph first, you guys. I would not write this. I think Connect Math would mark that incorrect. Okay. All X such that. What you want to do is you want to write it like staring at this. Okay. Kind of, sort of. Okay. If I look at that little piece, there's -3. And I can't remember, but I think it makes you write it like this as a compound inequality. I think it makes you write it together where it's saying, this is saying this, you guys. Okay, but it just makes it more succinct. If you look at it, does it have x is less than 2 written in it? Yeah, it's got x is less than 2 right there. So it's definitely saying this statement, okay? But then it's got your x is greater than -3 here. Yeah, it's backwards, right? That says -3 is less than or equal to x. So if -3 is less than x, then x is greater than -3, right? So that is this statement over here. So this is our succinct way of writing this inequality a little bit better to where somebody knows that it means the numbers between -3 and -2. Anytime you see a sandwiched inequality like this, right, then that is going to be a numbers between. Okay, so anytime you see a sandwiched inequality like this, it means the numbers between. So as soon as you see it, you know, oh, okay, whatever, it's these two numbers and all the numbers between them. Okay, so it's really good to know that, you guys. Because then you can just instantly visualize the graph must look like this down here, right? Okay. All right. For the interval, go to the answer down here that I just circled at the bottom of the screen, right? It's got the interval notation staring right at you. It looks like it's going to be a bracket. Oops, we'll just leave it in red. -3, and then a 2 with the parentheses. There's no infinities on this one, you guys. It didn't go off to infinity, right? And so that's why you don't see any infinities in our interval notation. Okay. Note, my answer would have been completely different if it had been an or. Just one little change in the word, and it actually would have been all real numbers. Because remember, for or, you take it all. So I'd have to take all of this, which goes to the right forever. I'd have to take all of this, which goes to the left forever. So in other words, I'm taking everything, okay? So it's really important that we know, that we look at the words, first of all, and we notice them, and that we know that and is the overlap and or means take everything that's been shaded. Okay. So let's go ahead and do this one. I'm just gonna do a quick multiplication by 2 to everything, you guys, to get rid of the fractions. Just makes my life way easier, okay? So 1x or x, 2 times 3 is 6, 2 times 5 is 10. Okay, so I'm going to solve that. So I'm going to move the x over to the left. We're dividing by a negative. So we must remember to flip that sign, right? Okay. And then we'll come over here and we'll do this one. Divide by 6. Just kidding. Okay. All right, so this time the word is or. All righty. Okay, so let's go ahead and get our 3 little graphs going, you guys. 1, 2, 3. We've got a, so this is one where people would mess up, but -3 is smaller, right? So sometimes when I get some tests, people put their number line wrong. Everything else they did correctly, but they miss it because they just didn't put -3 on the left, okay? All right, so this is going to be my x is greater than oops, -2. This is going to be my x is greater than or equal to -3. And this is going to be the combo of the two. So I am going to go to the greater than, so this way. Parentheses, because there's no line underneath, right? Then I'm going to go, oh, greater than. So I'm going to go this way. Square bracket, because there is a line underneath. So now, since it's an or, we're going to take everything that we see that's shaded. So I'm definitely taking this because this has been shaded, but I'm also going to take all of this because it's been shaded. Okay, so that's going to be our answer for the shading. Now let's go do our set builder and our interval. So for the set builder, we can write this much more succinctly, right? We don't want to restate all of this again. This is so long. That's not information that people need, right? So if we do this, all like such that, why don't we just, looking at the answer down here at the bottom of the screen, looking at the graph, why don't we just say x is greater than or equal to -3? That describes what I see shaded. I see numbers greater than -3 shaded, and I have a square bracket, so I need an or equal to on that inequality. I don't even need to bring -2 into the mix, you guys. Okay, so this is why we need to graph first. All right, for the interval notation, we know it's a square bracket. The smallest number is -3, and it heads off to infinity. So that would be our interval notation. All right. This is the exact same problem. They just changed the or to an and. The same problem, except the or has become an. So why don't we just go to those number lines? Okay, I'm going to go back and I'm going to kind of steal these. I'll try to steal them. Okay, and then I'll just draw one more. And so if we're looking at and instead of or this time, right? So we got x is greater than -2 and x is greater than -3, right? Okay. And means take the overlap, right? So I'm looking at where I've been shaded on both. I am not going to shade this region because it wasn't shaded on both. The overlap seems to be right there. So I'm going to shade that. Okay, I'm going to use a parentheses because that's what I see here on the 2 is parentheses. Okay, so that's going to be our solution for this one. So let me box it. We're going to do the set builder and the interval. All right, so for the set builder, again, we're just going to look at this graph and just write it as x is greater than -2, not or equal to, because it's a parentheses, right? And I don't need to bring -3 into it because it really didn't affect anything. And then for the interval, it looks like it's going to be parentheses -2 all the way to infinity. So totally say all the numbers are the same. The first two graphs are the same. But it's a big deal that we do look at the and the or because it gives us a different solution on each. Okay. So we already talked about the 3-part sandwich, compound inequality. And that just means the numbers between. So anytime that we see this, we know that we're instantly going to be talking visually about numbers between two numbers. Okay. And one thing to note is you will always use less thans or less than or equal tos. These will never have greater thans, okay? Now, that's not to say that when you're doing the math, a greater than might not appear, but know then that you got to flip the thing around because we're not allowed to have greater thans on these. They will always be less thans, okay? All right. So this one's already starting off with less than. Let's see what happens as we go in to solve it. Now for solving these, you want to isolate the x. You want to get the x by itself. So you're going to do what you would usually do about adding 3. But now we have kind of two sides of two equal signs, kind of, right? Inequalities, really. And so you have to make sure you do it in all 3 spots, you guys. Okay, one on the right-hand side, one on the left-hand side, and the one that cancels it out. So that is the only difference, is that you're doing it more than you regularly would have done it, right? We're going to divide by 2, but again, when I divide by 2, I've got to do it on all sides. I did not divide by a negative, so I'm going to keep the signs the same. Now we already know how the graph goes then. I already told you guys this means numbers between. So if I put a 1 and I put a 4, we know we're going to be shading between. Now, because there's a line underneath on this one, it's a square bracket, and there's no line underneath on this one, so it's a parentheses. So that would be our graph, okay? For our set builder and our interval, let's go ahead and write those out. Pretty straightforward. Our set builder is pretty straightforward, right? Squiggly bracket, all x such that, and then write your answer in that you got. It's much more straightforward than those last few where we had to think a little bit. And wow, the interval's like looking right at you. Okay, it's going to be a square bracket on the 1 and a parentheses on the 4. Okay. Let's try this one together. I am going to multiply by 5 to get rid of the fractions, okay? So I'm going to multiply by 5, make sure everybody gets it, don't miss anybody. All right, so 5 times 7 is 35. On that second term, the 5's cancel, so we just get 3x. 5 times 1 is 5. And 5 times 8 is 40. Okay, sorry, you guys, I'm kind of sloppy. All right, so the 5's canceled to give us that 3x in the middle, and now we're not dealing with fractions. So this is much easier to solve. All right, take away 5 on both sides, right, of the inequalities. Or you take away 5 is 35. Okay, divide by 3 again on both sides. And 3 doesn't go evenly into that, you guys, so let's just leave it. It's 35 thirds. All right, so easy graphs. Now it's going to be the numbers between. So we know we need to shade this way. All right, it looks like there's going to be a parentheses for the 10 and a square bracket. Okay. All right, so set builder and interval. So set builder, squiggly bracket, all x, such that 10 is less than x is less than or equal to 35 thirds. And then interval, parentheses on the 10, and square bracket on the 35 thirds. Okay. Now this one's interesting, 13. Okay, so you'll see what I've mentioned this, so you'll see what happens. All right, so we want to get the y by itself, right? So let's do the takeaway 1. Just make sure you do it on all sides. Right now I'm about to divide by a -4 on all sides. That means I need to flip the sign, right? 1 is greater than y is greater than or equal to negative divided by a negative is a positive, and 2/4 reduces to a half. Now this would get marked wrong, I believe. I would mark you off a little bit. Because I told you guys we never write sandwiched inequalities with greater than signs. So we need to flip the entire thing around, right? We never write, they call them three-part inequalities. Three-part inequalities with greater than signs. So flip the whole thing. All right, so we're just gonna put, plus you should always have the smaller number on the left. So 1/2 is smaller than 1, right? Okay. And then there's an or equal to sign on this one, and there isn't on that one. Okay, so always make sure all these ones that we've had so far, it's been smaller number. Okay, 10 is smaller than, gosh, what would this be? 11 and 2/3. Okay, same thing here. 1 is smaller than 4. It's got to be small and then big. All right, so then we graph this. Sorry. Excuse me. If we graph this, got 1/2, 1, between. We will put a square bracket on the half and a parentheses on the 1. All right, so for the set builder, oh gosh, all x such that 1/2 is less than or equal to y is less than 1. Then for the interval, it's going to be a bracket on the half and the parentheses on the 1. And this is just saying exactly what I told you guys, right? Where it's always going to be less than signs. This is good, less than, less than. This means I messed up probably somewhere because we have a less than and a greater than, right? So this is no good. Okay. All right. Okay, so we're going to talk about absolute value inequalities now. All right, so with these, let's just kind of talk about absolute value inequalities, you guys. Why they are the way they are, why the setups are the way they are. Hopefully that will help you maybe remember or rederive if you forget what the setups are, okay? So let's just take a look at 2 examples, okay? Let's take a look at the less than case. We'll just do less than or equal to make it easy. And then let's take a look at the greater than or equal to case, okay? So my claim is that if it's a less than, you sandwich it into a 3-part inequality. If it's a less than, then sandwich into a 3-part inequality. Okay. It's my claim for, you know what, I'm just gonna do this, you guys. Thank goodness for these smart boards, huh, or these programs. All right. If it's a greater than, then you're just gonna do 2 cases. Okay. Or equal to, right? I'm just basically talking about the sign greater than, or equal to. Do 2 separate cases. Okay. All right, so what that looks like, what the heck do I mean by that, is I would take x, the stuff inside the absolute value bracket, and I would sandwich it between 3 and -3. That would be the first step, okay? If it is a greater than, then you want to do 1 case that's exactly the same, but without the brackets. And another case where you've done 2 things, 2 changes. You flipped the inequality and you've changed the sign. So I say there's two signs to change. You got to change the inequality sign and you got to change the sign on the number. Okay. Now I remember a teacher just told me this and I was like, okay, yeah, and I memorized it. Less than, sandwich, greater, two cases. Okay. And that's fine. Okay. But I do always like to make sure that everybody understands and kind of, buys into that. Okay. So let me get a little number line going. Okay. All right. So let me go ahead and copy that. Put it over here. So what I'm going to do is I'm just going to like ask myself, what numbers can we put into the absolute value bracket? So I'll just have basically some empty absolute value brackets here and think, well, what would work? Right? What would work? Well, if I put a 2 in, the absolute value of 2 is 2. And yes, 2 is less than or equal to 3. So I know that I've got to go ahead and put 1 for 2. Same thing would be true for 1, right? If I put a 1 in, the absolute value of 1 is 1, and that's less than 3. 0, 2, you put a 0 in, the absolute value of 0 is 0. So that's less than 3. Okay. I can put 3 in because if I put 3 in, the absolute value of 3 is 3, and 3 is less than or equal to 3. So I could put 3 in. I cannot put 4 in. If I try 4, 5, etc., right? Okay, if I put 4 in, what happens is the absolute value of 4 is 4, and 4 is not less than. So I can't shade that, okay? All right, let's try some negatives. If I put -1 in, the absolute value of -1 is 1. And that is less than or equal to 3. So I'm going to go ahead and shade -1. And you can probably see that the same would be true for -2. What's going to happen if I absolute value it? It's +2, and it's less than 3. -3 would work. Some people might say all negatives would work, but not -4. If I absolute value -4, I get +4, which is not less than 3. So the region that I can technically shade would be this region, all those numbers, even decimals. I didn't use decimals because who wants to use them? But should I shade 2.5 here? Yeah. Okay, so I'm going to connect all these dots, you guys. Okay. So that's why we write it like this. Remember we said when we write a three-part inequality or a sandwiched inequality, what we are saying is the numbers between -3 and 3, right? The numbers between. Okay. All right, let's go over here to our other case. Why do I treat it completely differently if it's an or? So we've got our brackets. This time we want to know who's greater than or equal to 3, right? Well, 3 will work because the absolute value of 3 is 3, and that's greater than or equal to 3. 4 would work because the absolute value of 4 is 4, and that's greater than 3. 5 would work, etc. 2 will not work, right? The absolute value of 2 is 2, and 2 is not greater than 3. So I claim we're going to have a big piece in the middle that's going to be missing. Even -2 won't work because what happens when you take -2 and you absolute value it? It's +2, and 2 is not greater than 3. So we're going to have this big gap. We'll pick back up at 3, -3, and then -4 will work, right? Absolute value of -4 is 4, and that's bigger than 3. 5 will work. -5 will work, etc. So we have shading going this way forever. We have shading going this way forever, right? And technically, you guys, these are brackets if you want to put them in here. Okay. But so hopefully you can see that this or case does indeed have a gap in the middle. But this and case, this less than, right? It's sandwiched, it's the numbers in between. And so that's always going to be the case for these absolute value inequalities. So let's go ahead and dive in. We'll try some. We actually don't have too many more, you guys, before, actually we do, just kidding. All right, so let's go ahead and dive in and start these, okay? All right, number 14. All right, so since it is a less than, we are going to sandwich it. We're going to take the 2x plus 3. It's going to be less than 5, and it's going to be greater than -5. So you can see that the original is right here, right? Basically, we're just tacking on this extra little bit. It's a good way to think about it. All right, so let's go ahead and solve this three-part inequality. So we'll take away 3 from all sides. And we'll divide by 2 to all sides. Oops, sorry, not to be flat. All right, -4 is less than x is less than 1. All right, so we know that that means the numbers between. So we're going to go ahead and put, oops, -4 on here. We're going to put 1 on here. We're going to shade the numbers between. And both are going to be parentheses, right? Since there's no or equal to's. Okay, so a couple things. Since it's a less than, sandwich it, right? Right. And then let's go ahead and do our set builder and interval notation for this. Okay. Oops. Set builder, squiggly brackets. Oops, I forgot all x such that, right? Just kidding. Oops. Erase, guys. All right, all x such that, and then write that, right? For the interval, it looks like they're both going to be parentheses, both the -4 and the 1. Okay, so any numbers that you pick in this range should work when you plug them in, right? So let's see here. 0's in this range because 0's right here, right? You plug 0 into the original, this part will go away, right? And so you have 3 is less than 5, and indeed 3 is less than 5. Okay, so you're basically telling people, hey, all the numbers in between here should work. All right. Now, don't do your 2 cases until you've isolated the absolute value. I didn't stress that. That is a big thing. Don't do your 2 cases or sandwiching, right? Until the absolute value is isolated. Okay. So we want to make sure we isolate it first. So that's going to be our first steps on this one, okay? So in other words, I got to get rid of that 2, you guys, or else we'll get the wrong answer. I used to teach Algebra 2 in high school. That would be like the #1 reason why somebody might miss this. They did everything else right. They knew when to sandwich it, and they knew their 2 cases and stuff, but they would end up doing it too soon. That is a 9. Better rewrite that. Okay. It's a less than, so we're going to sandwich it again, right? So 2x plus 5 is less than or equal to 9. That matches. And then we'll just add this greater than or equal to -9. And we'll solve. So we're going to subtract 5 from all sides. And we'll divide by 2 to all sides. Okay. So for our graph, 7, we've got 2, we've got the numbers between. They're both going to be square brackets on this one. Let's do our set builder and our interval. Set builder. So for the set builder, squiggly bracket, I won't forget my all x such that I'm just going to write my answer in. Then for the interval, hey, it's staring at us. Just look at that number line, square bracket, -7, square bracket 2. All righty. Oops, sorry, guys. I skipped one. I didn't. Okay. All right, we talked about this. So remember, isolate it first. So we're going to have to add the 1 first to both sides. Don't do your 2 cases yet, right? And we still have to divide by 5. Now we have isolated the absolute value. So now we're ready to decide if it's going to be sandwiched or if it's going to be two cases. Since it's a greater than, right? It's going to be two cases. Remember, one case is exactly the same without the absolute value brackets. And the other case, you have to change two things. You got to change the sign. So instead of a greater than, a less than, and you have to change the sign. So you got to change the sign, you got to change the sign. So instead of a positive 2, a negative 2. And then you just proceed to solve these guys. Oops. 5/2. And it's an or, by the way. Did I put or on the original? We put an or here just so you guys know. It's really important that it's an or. So I'm surprised I left that off. Okay. All right. And then we'll solve this other one. Okay. So this goes back to what we did earlier, right? Okay. So, and by the way, I mean, with these will always face away from each other with absolute for the or case. Okay. For the two cases, the graph will always face away from each other. Unlike with the and case, right? All of our graphs, if you think about it, they went towards each other. Okay, so instead of -7 going this way and 2 going that way and them going away from each other, they went towards each other, right? They went toward each other and created this space between. Well, what we're saying is that the or case will always be like this. One's going to go one way and the other's going to go the other way. They're going to go opposite of each other. Okay, so they'll always point away. So knowing that's only with absolute values, you guys, it's not with ors. And you could go back and do your 3 cases if you wanted to. Okay, so we got 1/2. We've got 5/2. With absolute values, they're always going to face away from each other. Now there's no bracket. I mean, there's no line underneath on these, you guys. So that means that they're going to be parentheses. Okay. So let's go ahead and do our set builder and our interval notation for this. Okay. So for the set builder, we can use the or we can use the union. So x is less than, or I guess maybe they would probably have you use the or. The union's for intervals, so don't mind me. I don't know what I'm talking about here. Okay, so for the interval notation, right? It's going to be, let's describe this one first, right? So that one keeps going to the left forever. So negative infinity all the way up until 1/2, and both get a parentheses. Infinity always gets a parentheses, and 1/2 clearly has a parentheses from the graph. We'll pick it up on the other side from 5/2 all the way to positive infinity. And that will be our solution. So with absolute value inequalities, less thans always go toward each other, and then greater thans always go away from each other. All right, I'm going to get rid of the fractions on this one first. By multiplying by 5, we do have to isolate the absolute value. And so that is one way of doing it, right? So the 5s will cancel. So we have 3x plus 3 greater than or equal to 15. Okay. All right, so now we can do our, well, let's see, it's a greater than. So we know that we have to do 2 cases, right? One case that's exactly the same. And one case where I changed this sign and I changed this sign. All right. Okay, so let's go ahead and solve these, you guys. Takeaway 3. And then that's an 18. What am I doing? And then divide by 3. Okay, let's do the math over on this one. Take away 3. 15 minus 3 is 12. Divide by 3. Remember, it's always an or, right? Which means they will be facing away from each other. So I'm going to automatically shade away. There's lines underneath, or equal to's, in other words, so square brackets. Okay. So let's go ahead and do our set builder and interval. All right, so set builder, squiggly brackets, all x such that x is less than or equal to -6, or x is greater than or equal to 4. That's a 4. Looks like a 6, doesn't it? Okay, let me try that again, guys. For the interval notation, it is going to be 2 pieces. So I have a union sign. It's going to go from -infinity all the way to -6, bracket, union. And then from 4 all the way to infinity. All right. Okay. So for this one, it is a greater than. So we should do 2 cases, but you can see that the 2 cases would be silly, right? I mean, I could do 2x plus 1 is greater than or equal to 0, but I can't really do 2x plus 1 is less than or equal to -0, right? That doesn't make any sense, -0. So we're really just going to solve the one case, you guys. Okay, so any number greater than -1/2 should do it, right? So any number greater than, so this way, it does have an or equal to symbol on it, right? So it's going to be a square bracket. Oh. Right. All x such that, so squiggly bracket, all x such that x is greater than or equal to -1/2. And the other one would be -1/2 with a square bracket all the way to infinity with the parentheses. You've already, with what we did earlier, with the absolute value equations, which was, last section, you already know how to solve these, okay? So what you really want to focus on for these is the setup. That right away, when do I do 2 cases? When do I sandwich it into a 3-part inequality? Make sure you really have that down solid, because if your step 1 is wrong, the whole thing is wrong, okay? All right, this one's actually going to be no solution. I love ones like these because I don't have to do a ton of work. Let's talk about why it's no solution. The left side is getting absolute value. So it's either 0 or positive, right? The left side is being absolute valued. So it's non-negative. So if it's 0 or positive, let me put 0 or positive, right? So it's either 0 or positive. So it could never be less than a negative, right? A positive can never be less than a negative. So this is going to be no solution. So remember that they would probably only do set builder for that, you guys. They would not do interval. And for the set builder, It's just going to be empty brackets. So the graph would be a graph with nothing on it, right? Nothing shaded. There's my 0. Okay. I love these because I don't have to do a ton of work, right? It's like, this side's positive or non-negative, I should say. So how's it going to be less than a negative number? It can't. All right, let's go ahead and go in here and do a couple word problems, okay? So absolute value inequalities, they have applications in the real world in what we call tolerance problems. So consider the example of you working at like an M&M factory. Let's say that your factory makes those fun size M&M packets that they have for Halloween. And let's say that for the fun size M&M packets, let's say you want, I don't know, 16 M&Ms in a container, okay? So let me go ahead and write down a few things. Absolute value inequalities, oops, are used in the real world in tolerance problems. So they're called tolerance problems because you'll tolerate some error. You don't have to be spot on. A range of numbers is fine, right? So let's consider our M&M problem, okay? Consider that you work in an M fun size factory or factory or fun sized packs of M&Ms. Ideally, you want 16 pieces in a bag, but sometimes the machine shoots out more or less, right? An extra one might sneak in there, right? That's the pack you get, okay? So let's say that you'll tolerate an error of 2. You will tolerate an error of 2 on either the high or the low side. Right. So, in other words, anywhere from, let's see, 2 less would be what, 14? To 2 higher would be 18 will be accepted. All right, so how we tend to write that with these absolute value inequalities is we have an absolute value of x minus whatever the goal is, minus the goal, the desired amount. And that's less than or equal to whatever, the error. It's always a less than sign, okay? Always a less than. It might be less than or equal to, but it's always a less than. So never a greater than or greater than or equal to. Always less. And I should be putting quotes in these. Just easy. This is an English class. All right, let's see here. I probably should be modeling proper stuff. There we go. So if we set that up in this case, right? In this particular case, our goal is to get 16 in a pack. So we want x minus 16 less than or equal to an error of 2. Now you'll notice since it's a less than, we know that it's going to get sandwiched. So the x minus 16 less than or equal to 2 is also going to have a negative 2 on the other side. Now I claim that when you solve this, you should get what we want. Here's our 14. These cancel. And here's our 18, right? So anywhere in between 14 and 18 would be acceptable. And these show up all over the place. These tolerance problems. You guys will probably start to see them now a lot. You'll be in a science class, you'll be even an automotive class, you know, something mechanical. And you'll notice that there's tolerance. So here's an example right here, okay? The pH of the water in a public swimming pool should be maintained at a safe swimming value of 7.4. Slight variations in the tested value of the pH levels are acceptable, but should differ from the ideal pH level by no more than 0.02. If X represents the exact pH value tested, write an absolute value inequality that represents a safe interval for X. So if we use this whole X minus the goal is less than or equal to the error, right? Then how we would set this up is it would be, well, we want there to be 7.4 in the pool, right? But we're okay with an error of 0.2. So now it says to solve that inequality, well, it's a less than, so that means it's going to get sandwiched, right, into a three-part inequality. One is exactly the original, and then we just need to sneak a negative 0.2 on the other side, always less thans. All right, and now we have to solve this. So we're going to add 7.4 on both sides of the inequality. So this will be 7.2. We're okay with that kind of a pH. And this one will be 7.6. Okay, so to interpret it, an acceptable pH level would be anywhere from 7.2 to 7.6. Okay. So pretty cool. Like, why do I care about these absolute value inequalities? Well, there's an example, okay? All right, let's try this one. One cell phone service charges a flat rate of $35 per month plus 1 cent per text. Another company offers a flat monthly fee of $50 with unlimited texting. How many texts would you need to send for the first company to charge you more per month than the second company? All right, so let's go ahead and go in here and write out, let's write equations for the two companies and set them equal to each other. Okay, to see when they equal each other, right? To see how many texts need to be sent for them to have the same price. Write equations for the two companies and set them equal to each other to see how many texts need to be sent for them to have the same price. All right, so for company number one, they're charging you a flat rate of $35 plus 1 cent per text. So don't forget to write one as 0.01. I have some students who put 0.1, and that's actually 10 cents, right? 0.01 would be 1 cent. Then the other company is just going to charge you a flat 50. It's not like $50 per anything. It's just a flat rate of 50. So we've set the two companies equal to each other, right? Okay, so now we're going to go ahead and solve for the X. So we'll start by subtracting 35 from both sides. And then we could just move the decimal place twice to get us 1x on this side. But you would have to move the decimal place twice here to get you 2 extra zeros. So you'd have to send 1,500 texts. And I know that sounds like a big number, but have you ever kept track of how many texts you send in a month? I mean, maybe it is that close, right? Okay. So once you send 1,500 texts, they'll both cost the same amount. So once you go past 1,500 texts, then we know that this company that's giving us a flat $50 with unlimited texting would now be cheaper. So let me read the question to see what they want. How many texts would you need to send for the first company to charge more than the second company? Okay. If we send 1,501 texts, the first company would be more, would cost more. All right, so Hopefully that makes sense to you. Now you're probably going to go check and see if you can figure out how many texts you send per month, right? Okay, I'm always mortified when it tells me my screen time. I'm like, oh my gosh, get alive, right? Anyhow, all right, guys. Hopefully, this made sense to you. Sorry for kind of a long video. There's a lot to cover. Again, this chapter one's kind of crazy, but guess what? That finishes chapter one. So great job, and as always, good luck on the homework.